Hello everyone, and thank you very much for joining. Today, in under 4 minutes, I'll show you how to turn a stateless RAG system into a stateful support agent with persistent memory using Cognee. Everything you see is fully reproducible using the provided Colab. To give you some background, traditional RAG systems answer every query in isolation. They don't remember past interactions, they don't understand relationships over time, and they lose context between conversations. For customer support, for example, that is a serious limitation, because history matters. Cognee fixes this by adding long-term memory. It builds a knowledge graph, preserves context across sessions, and combines vector search with graph traversal. On top of that, feedback loops allow the system to improve relevance over time. We begin with installing all of our dependencies and afterwards importing our libraries. Then we quickly need to configure our API keys. That is basically just the OpenAI key, which we set as OpenAI key as well as LLM API key. Right. Now that we've done that, we continue by downloading the dataset we'll use in this example. In this case, it's a customer support ticket dataset by Kaggle. All right. After we've downloaded our dataset, we can now continue and quickly inspect our data. In this case, we can have a look at the number of resolutions, first-time responses, the time to resolution, as well as the general customer rating, and also have a look at how many different ticket types we actually have and what types they are. The same counts for the ticket status as well as for the ticket priority. After looking at the data, we now need to transform it into a natural language document that combines ticket text, priority, status, and resolution. This makes the data ideal for both LLM reasoning and search. Okay, now that the pre-processing is done, we can start and build our first stateless RAG agent. How do we do this? We define the embedding model using the sentence transformer and use files for the index. Then we create our RAG query function. We set our query model, the distances and indices. Again, we can define our top K here. And then we set our relevant docs. That's the ones we pre-processed beforehand. We set our context, and then we defined an elaborate prompt for the RAG query. We use the context defined beforehand as well as the questions and how the answer should look like. And now, once we run this, we can actually ask questions to this RAG model. You can see the questions as well as answers here. Keep in mind that this works, but it's only stateless. So follow-up questions don't reuse prior context or relationships, and you can only ask single stateless questions. Now that we have seen how a stateless RAG system responds to your questions, we can now check out what it looks like when you leverage a library like Cognee. So in our case here, we first define some Cognee data using the pre-processed data again. And then to make sure we start at a clean slate, we prune all the Cognee data. Then we just add the data, the Cognee data, to Cognee using the add command. And that is basically it. If you have any difficulties with how the pre-processed data looks like, you can also do this in simple batches. This is why the try except loop is here for. And in this case, you just add the batches step by step. And yeah, that's already it. Once that is done, we start by cognifying the data. What is actually happening here? So you can think of the .add command or pipeline as a sort of staging, whereas the Cognify is actually trying to cognify the data you've staged, so actually creating the knowledge graph and everything that's going on under the hood. To give you a better understanding of what has happened under the hood, we also added a visualization, so you can actually have a look at the knowledge graph. We added some code here, so you can look at this in the output. But of course, the file is also stored in the root directory. You can just download this and then open it in your browser. Now in the browser, you can have a look at the different entity types as well as entities. So for example, this is the entity shows. You also have different ontologies here, as well as you can look at the document chunks and general text files. You can probably take a minute and have a look at what we've actually created here. Of course, the obvious question now is, how does the results actually look like? And for this, we simply use the Cognee search function. And once we print this, you can see that the results we get are actually a lot different. They contain more context and are more semantically relevant to the questions you've actually asked. Plus, it is also possible to ask follow-up questions, which wouldn't have been possible with a stateless RAG system. Lastly, we also want to emphasize that you can actually provide feedback to the graph. So in this case, we use the search function with the additional search type feedback to enforce edges between entities, and therefore you can even improve the data we've processed so far. Another thing you do not have with a stateless RAG system is to provide you with semantically relevant summaries. So in this case, we can actually ask, for example, what patterns do you see with Marisa O'Brien's support history? And a usual RAG system would just give you a summary of all the different collections what it found. In this case, here it can really give you an accurate answer of how this customer looks like and what recurring problems are. All right, I hope you enjoyed the video. If you have any questions, feel free to just drop them in the comments. You're also always welcome to join our subreddit as well as Discord. And yeah, looking forward to see you in the next video.